All right, so this is simply decimal equivalence. So you have to, part of your knowledge of fractions is understanding that things can be written in different forms. So the other day we talked about different forms, different fractional forms. Don't write this. For example, somebody tell me another way for me to write the fraction 1/2. Give me another fraction that's the same as half. Nia? Another fraction that's the same as half. You're too far ahead of me. Go ahead. 2/4. Okay. So the other day we talked about equivalent fractions, and we could write 4/8 and 11/22, and we could do a whole bunch of stuff that's equivalent to a half. Or, Nia, we could write the decimal equivalent, which would be 0.5. So again, the point here is now we've got to understand that there's different ways to represent the same thing. 0.5 is the same thing as a half. It's the decimal equivalent. And there are certain decimal equivalents you guys should have in your brain. If I said a 1/4, what would be the decimal equivalent? 0.25. All right, that one we should have in our brain. 3/4. 0.75. That should be in our brain. Do you know 1/5? 0.2, right? 1/5 is 0.2. Therefore, 2/5 is 0.4. 3/5 is 6. 4/5 is 0.8, and on. Those definitely you should just have in your brain. So we're going from a fraction to its decimal equivalent. It's just another way of saying the same thing. Fractional form versus decimal form. In addition to that, there's a lot of different ways to even look at a fraction. We'll talk about more of those as we continue on. But when you're given a fraction and they want the decimal form and you don't readily know it, there is a way to figure it out. And what do you simply do? To change a rational number to a decimal, divide the denominator bottom into the top. You can't get that backwards, okay? The bottom has to be divided into the top. Now just pause for a second. Look, that's what the fraction means anyhow. Okay? The bottom into the top. Now what gets students confused? Let's look at the 3/8 right here. Don't write anything. I'm just trying to get you to think. All right, so what is 3/8? Basically, you can think of it this way. I have 3 out of every 8. 8 would make a whole. I have 3 of them. I have 3 of the 8 necessary to make a whole. So do I have less than a whole or more than a whole? I have less. I only have 3 of the 8 I need to make a whole. 3 of the 8ths. Now, how do I get its decimal equivalent? I divide the 8 into the 3. I'll get a number less than 1. And I'll figure out its decimal equivalent. You know, don't write this. If we had something simplistic as 10 divided by 2, I have 10 of 2's. So we all can divide 10 by 2, right? 10 divided by 2 is 5. And what indeed do I have? I have 5 holes in this case. It only takes 2 to make a hole. I have 10 parts. So first 2 makes the first hole. The second 2, right, makes the second hole. The third 2, I'm up to 6, makes the third hole. The next 2, I'm up to 8, makes the fourth hole. And then the last 2, I'm up to 10, makes the 5th hole. Right? There's a couple different ways of looking at fractions. But honestly, to come up with the decimal equivalence, if it's not something you already know, all you simply have to do is take the bottom and divide it into the top. Now, when we have our calculators, this will be a breeze. You'll punch buttons. Pretty simple. Before then, we got to do long division, and that's not a big deal. So let's refresh our memory on long division. All right, we need a decimal point. And I'll bring that up top. And we need a 0 placeholder, right? Because we got to divide the 3 into the 8. I mean the 8 into the 3. So 8 can't go into 3, but 8 can go into 30. And 8 goes into 30 how many times? 3. And again, 3 times 8 is 24. And this isn't a lesson in how to do division, but it kind of is. All right, so now we need another 0, right? And now we got to divide 8 into 60, and 8 goes into 60 how many times? 7 times, and now we get a 56. And we get a 4 left, and we need another 0. And 8 goes into 40 how many times? And finally we're done, right? Because that gives us a 40, and finally no remainder. So what's the decimal equivalent of 3/8? 0.375. So if you did this on a number line, right? If you did it on a number line, and don't do this, I'm just trying to get you to think. If this were a half, about where would you put it? And hopefully you would say, oh, I'd put it maybe about there, would be about 0.375. Because remember, this half mark is 0.5. Right? And that's where 3/8 would be. Is 3/8 less than a half or more than a half? Less than a half. Look, 4/8 is a half, isn't it? So we're an eighth less than a half, so somewhere in there. All right, but decimal equivalent, pretty easy. We got to take the bottom and divide it into the top. Okay, so let's do the next one. We'll take the 11 and we'll divide it into the 3. All right, now stay with me on this one. Again, we need a decimal point because 11 doesn't go into 3. Put the 0 out front, and we need a 0 now. 11 goes into 30, and everybody says 2. We got a 22. That gives us an 8. And we need another 0, don't we? 11 goes into 80. How many times? 7. And we get a 77 remainder of 3. Does that 3 mean anything to anybody? Does that have any meaning to you? Allison, what meaning does that give to you? I am going to start back at the beginning. I'm at a repeat. We started with a 3. We added the 0. We now have a 3 again. Therefore, we're at a part where this number repeats. Now, if you don't see that, you're going to have to do a few more places until you see the repeat. Let's assume you didn't see it. And I know we're out of room here, so I'm going to go up here with my 3. So let's go 30 again. 11 goes into 30 how many times? 2. And so again, we're at 22. And again, when you subtract, you get an 8. You see how we're right back? So again, maybe you still don't catch on. And you do another 0. So now we're at 80. And again, you would do 7 again. And do you see the repeat? It's going to be 2, 7, 2, 7, 2, 7, 2, 7, 2, 7. Now, do you know how to write your repeaters? I hope you do, right? I hope you decide. So here's let's come over here. So here's my final answer. You only want to write the repeating part one time, and then the bar goes over it. So 0.27 with the bar over the 2 and the 7, because that's the repeating part. 27, 27, 27, 27. Chloe. Sorry, too loud in the hall. Chloe, can you ask your question again for me? The 0 is not necessary. Make sure you have the decimal point. Some people prefer the 0 because it makes the answer more clear. But no, that is optional, and I've seen it either way. I got to clear a little bit of this space. All right, so go ahead and try C. Go ahead and do C yourself, see what you get. All right, so hopefully you got, let me unfreeze this for you guys, 0.583, and the bar is just only the 3, over the 3, correct? Because you keep getting 4 every time. 4, 4, 4, 4, 4, 4, 4, which would give you 3, 3, 3, 3, 3, 3, 3, 3, forever 3. And so 0.583 bar only over the 3. How many got that correct? Okay. Try to learn. If something's getting you, try to figure it out. All right, go ahead and do D. I'm going to pause and do D. And hopefully you ended up with, did you keep it negative? All right, because remember, negative divided by positive is negative. Negative 0.46 bar over the 6. That 10 keeps repeating, right? So this one's 0.466666666 and a whole bunch of sixes. Now, let me remind you what I always do with a negative. I always put it right up in the top right away. When it goes up top, then you can count it as a positive underneath, right? You're just making sure that you end up with a negative number. Question, Brennan? You shouldn't have gotten 0 there because when you get your 10, if you did a next number, you would bring down another 0 and you'd be at 100 again. And 15 goes into 100 6 times. So you should have gotten 0.4666666, which is 0.46. Do you see that? Or was I clear? Okay. Wasn't sure if I was clear for you. All right. Be careful with your repeaters, and hopefully you'll get good at them. All right, number 2. Number 2, don't forget how to convert an improper fraction to a mixed number. We've actually done some of this already, so this is a quick refresher. Well, this is the same procedure. You're going to take the bottom and you're going to divide it into the top, right? The only difference here is we're going to do a fraction instead of a decimal, right? So this is going to be a negative, right? 7 goes into 8 once. 7 goes into 15 twice. And here's the difference. We're not going to do a decimal point, right? If you're going to a mixed number, you need the whole number part. And we all know to take our remainder and put it over the divisor, right? So negative 12 and 1/7. Negative 12. No decimals on that one. We're changing to a mixed number. Okay? So it starts the same way. The only thing is we don't go with a decimal equivalent. Okay? Could we ask you to turn an improper fraction into a decimal equivalent? Yes. In that case, you would keep going and keep doing the division with the decimal point and get a decimal answer. So improper fraction, nope, stop at the decimal point. They want you to keep going, keep going. All right, number 3, to convert a non-repeating decimal to a fraction. This is one that gives students a little bit of trouble, but it's not too hard if you learn the procedure. All right, so there is a procedure. All right, so how are we going to do this? We're going to convert a non-repeating decimal to a fraction. This thing doesn't repeat. All right, what's the trick? Multiply by a form of 1 according to the number of decimal places. And we have to make a correction here in your notes. If there's 1 decimal place, use 10. This next thing should say 2 decimal places. So change that 1 to a 2 and change place to places. 2 decimal places, you'd use 100 over 100. 3 decimal places, you would use what? 1,000 over 1,000. Hopefully you don't have to do any like that, but if you did, it'd be 1,000. 4 decimal places, 10,000 over 10,000. All right, that's the idea. I've got a couple examples here. So we're going to multiply this by what over what? 0.15 by what over what? 100 over 100, because there are 2 decimal places. So we're trying to convert to a fraction. Now, most students, it helps them to put the 0.15 over 1. You don't have to, but most students like that. Okay, now we're just going to do multiplication. What's 0.15 times 100? You should be able to do that in your head, right? 15. If you chose the right thing, you will not have a decimal anymore. That's why we chose 100, to get rid of the decimal. So we're at 15. And the bottom 1 times 100 is 100. And what do you do to finish, by the way? You got to reduce the fraction that you've just produced. So let's reduce. What is a 15 of 3 times 5? Isn't 100 a 20 times 5? Now, again, I know that, right? How many nickels in a dollar? 20, right? And now what's 5 divided by 5? That goes away. That's 1. And what are we left with? 3/20. So, hey, you know what? The fraction 3/20 is 0.15. So this is a non-repeating decimal. We can turn it into a fraction. 0.275. Go ahead. Yes. 0.15 times 100 and got 15. Right? That's 0.15. So on this next one, we got to get rid of our decimal place, and there's 3 places. So we got to multiply by 1,000 over 1,000. And again, a lot of students like to put the 0.25 over 1 just to keep track of the tops and bottoms. So on this one, 0.275 times 1,000 is 275, and the bottom is 1,000, and now we got to reduce. If you had $2.75, how many quarters would you have? If you had $2.75, how many quarters would you have? Can't you do that in your head pretty easily? So isn't this 25 times 11, right? If you had $10, how many quarters would you have? How many? If you had $1, how many quarters do you have? If you have $10, how many quarters do you have? 40, right? So again, that can just save you a little time. If you can't do that, just reduce it normally. But I wanted to get rid of the quarters, right? 25 divided by 25 is 1. And what fraction is this? 11/40. Okay. Now again, maybe you couldn't do the quarter thing in reducing. You could reduce it the other way. You can do a 5 and then more, another 5, and you can do a 10 and 5s from there. Now I want to see your work, so your work will look like that. This way I know you're getting it from the way you're supposed to instead of punching it into a calculator or punching it into the internet, okay? So I need to see your work. All right, here's the last thing. And hopefully I'll get to both of these examples. Converting repeaters to a rational number, which is a fraction, is a little tricky. And by the way, rational number means fraction. Not a big deal, just slipping that in to get that in your thought. All right, well, here's a repeater, and these are a little bit tricky. There's a process to it. So let me do this with my shade, if I can, so I can focus your attention. Okay, the first thing you want to do is make an equation. This is pretty simplistic. We're going to use, let's use n, and do equals, and then write what you have. 0.27 bar, right? We just made an equation, which means we added a variable and we put an equal sign. That's not too hard to do. The next step is the key step. We have to multiply both sides by 10 to the n. Ooh, what in the world does that mean? All right. Remember this one back here? If it was 1 decimal place, we had to do 10 over 10. If it was 2, we had to do 100 over 100. If it was 3, we had to do 1,000 over 1,000. It's the same situation here. How many decimal places are there? 2. So what do you think we're going to multiply both sides by? 100 times 100, 10 squared. So don't get all caught up with the 10 to the n. If this was, the bottom one is 0.5, what would we be multiplying both sides on that one by? 10, right? Because it's just 1 decimal place. You follow? All right, so let's use our color. In green, do 100 on the left, do 100 on the right, and then still write your blue, times n times 0.27 bar. I multiplied the left by 100, I multiplied the right by 100. Let me let you catch up and have that sink in. And again, why did I choose 100? Because it was 0.27. It had 2 decimal places. All right? The next step is to subtract the original equation. Let me show you how to do that. Stick a red negative on the left and a red negative on the right. Oops, I'm ahead of us. My bad. I will get in trouble if I drive you guys crazy. All right, before we do step 3, we got to multiply this out. So what is 100 times n? 100n. All right. What's 100 times 0.27? Here's the tricky part. All right, everybody watch this. It's 27.27 bars still if you multiply times 100. You always keep that repeater part. And I know that's tricky, right? Because remember, what is the number really? 0.27272727, right? It keeps going. You'll see why we kept that 0.27 part in a minute. Okay, now we got to subtract the original. So this step's going right here, right? And guys, what was the original? It was this part, right? So we have minus n on the left and minus 0.27 bar on the right. Subtract the original equation we made. Okay, so let's draw a line so we can total it. 100n minus 1n leaves you what? What's 100n minus 1n? 99n. Do you agree? Right, 100 minus 1, and n is a 1n, isn't it? Right, 100n minus 1n is 99n. Okay, on the right side, you've got a 27 minus 0 gives you the 27. And what's the 0.27 minus the 0.27? Nothing. So what does the right side end up? 27. If you do it right, the decimal part will always be gone. Because remember, we're trying to get rid of the decimals. Okay. Again, I know that's a little tricky. I understand that. The last thing you do, number 4 now, is solve this equation. How do we move the 99? Somebody tell me how to move this 99. Christina? Kristen, sorry. Divide both sides by 99, right? Where am I at right now? N equals 27 over 99. And you know what the last thing I have to do is, and I got to put a number 5 here, reduce if possible. And I should have given us like one more line here of space to do this. All right, so what is a 27? It is a 3 times 9. What is a 99? A 9 times 11. Do you agree? So when we divide out our 9s, what are you left with? 3 11ths. And 3 11ths is indeed 0.27 bar. Now, again, that's tricky. I know that's tricky. That's the way it works. When you do a few, it's not so bad. Are you going to do a ton of these on quiz and test? No. You might have like 1. Let's try again here. I don't think we'll get to that third one, but let's try the second one. 0.5. What's the first thing you do? Say it if you know it. Make an equation. N equals 0.5 bar, right? Next thing. Multiply both sides by what? 10. So I'm going to multiply the left by 10, and I'm going to multiply the right by 10. Okay, what does this equal? The left is 10n, correct? What would the right equal? 5.5. You always have to keep that decimal part. Because remember, a 0.5 bar is a 0.5555555, right? You always got to keep that decimal part. Okay, now what do we do? Subtract the original. What's our original? N equals 0.5 bar, right? What do you get on the left? Right? 10 of them minus 1 of them is 9 of them. What do you get on the right? 5. How do you finish? Divide both sides by 9. And this one, there's no reducing. N equals 5/9. N equals 5/9. I don't think we have time for the last one. It would be the same procedure. If you really want to, you can try it on your own at home if you want to. Or you can wait till the homework and do the ones there, right? So, I'll give you a bonus on the quiz, though. All right, so you got your homework there for tonight. And quiz mañana. Quiz mañana.